A 25-foot ladder is placed so that its height on the wall is 3 feet more than triple the distance from the base to the wall. Here I'm going to draw a picture to basically model the information. So I have the wall that the ladder is leaning against. I have the distance that the base of the ladder is from the wall, and then I have the ladder itself. Whenever I have a ladder leaning against the wall, it's a 90-degree triangle. So here I'm going to label the information I have. So 25-foot ladder, so that is this side, is placed so that its height on the wall, I'm going to call that A, and you'll see why I'm using A in a moment. So the height on the wall is 3 feet more than triple the distance from the base to the wall. So this is my base, and A is 3 plus 3b. Now whenever I'm solving the unknown sides of a right triangle, I have the Pythagorean theorem, which is a squared plus b squared equals c squared. So I'm going to plug the information in that I have. I have that a equals 3 plus 3b. So I have 3 plus 3b, and I have to square that, plus b squared equals, and c is always the hypotenuse, the side directly across from the 90-degree angle, and that equals 25 squared. Now, it's very important that when we see this, we remember that what we're actually doing is that binomial times itself. This means that we have to FOIL, or we're distributing both terms to each binomial as we multiply. Okay, and then 625. Okay, so I'm going to go ahead and do my FOILing. So 3 times 3 is 9, plus 3 times 3b is 9b, plus 3 times 3b is 9b, plus 3b times 3b, which is 9b squared, plus, I need to not forget that b squared. B squared equals 625. Okay, now I need to combine like terms. So I get 10b squared, that takes care of those, plus 18b plus 9 equals 625. Notice it's a quadratic because I have a b squared. So I need to get this equal to 0. So I subtract 625 from both sides, subtract 625 from both sides, and I get 10b squared plus 18b minus 616 equals 0. Okay, so now I'm ready to factor. I need to take out a common factor, and I can take a 2 out of every term. So I get 2 5b squared plus 9b minus 308 equals 0. And notice each of these are the original values divided by 2. Okay, so this 2 actually can be divided out, so I can just get rid of it. Remember that this is multiplication, and in order to cancel multiplication, you divide, and I'm dividing both sides by 2. Okay, so now I have 5b squared plus 9b minus 308. I have a coefficient other than 1, so I want to multiply my first and my last terms. So I get 5 times negative 308, which equals negative 1,540. So I need to create the middle term of this quadratic by finding factors of negative 1,540 that add up to 9. After a bunch of attempts, you come up with 44 and 35. If you multiply those, you get 1,540. Now we need a positive 9, so my larger factor is going to be positive, my smaller is going to be negative, and now I rewrite the middle term. So I get 5b squared plus, actually, I'm going to switch that. I'm going to do minus 35b plus 44b, that's the rewriting of the middle term, minus 308 equals 0. Now I need to do factor by grouping. I group these two terms, and I group those two terms. I take out 5b, so b minus 7 plus, now I need a common factor of 44 and 308, and actually 44 goes into both of those. So I'm going to take out the 44, and I get b minus 7 equals 0. My factors are 5b plus 44 times b minus 7, that equals 0, and now I need to do the zero factor principle. Okay, so this one is 5b plus 44 equals 0, and this is b minus 7 equals 0. Now, in order to solve this one, I need to subtract 44 from both sides, so I get 5b equals negative 44. As soon as I get a negative on the right-hand side, I know that can't be the answer because I cannot have a negative dimension. So in this case, this answer does not work. But if I add 7 to both sides, I have a positive dimension, so I know that b has to equal 7, and the units are feet. Okay, and that is how far from the wall is the base of the ladder, so it's 7 feet. Okay, now I'm going to go to the next slide to show the answer for the next part of the question. Okay, so I know that the distance from the wall to the base of the ladder is 7 feet. That's what I just solved. So now I have how high does the ladder reach. So I'm going to redraw my picture with the information that I now have. And I know that b is 7 feet. I know that my ladder is 25 feet. And I know that a is 3 plus 3b from that original equation. So I'm actually solving for a, the height of the ladder. And I just need to plug b in, which I got on the previous problem to solve for a. So a equals 3 plus 3 times my b value, which is 7. So I get 3 plus 21 equals 24 feet. So my final answer for how high the ladder reaches is 24